Hi everyone, and welcome back to Casper's dApp Developer Series. In today's video, we'll be writing a smart contract with payable entry points, which are smart contract functions that have the ability to accept CSPR and deny users access if they don't provide sufficient funds. We'll also write an entry point that allows depositors to withdraw the funds they've deposited. Start by opening a terminal and navigating to the directory you'd like your project stored. I'll start from the home directory. Create a new Casper Smart Contract project by running cargo Casper and then your project name. I'll name mine Bank Contract. Open a File Explorer, head to your project directory, go to Contract, SRC, and open main.rs. Delete lines 19 and 20, and then everything after line 32. Let's import everything we need. We'll use the vec macro to create vector arrays and toString so we can build string objects from string literals. Next, we'll use some classes from the Casper contract crate. We need runtime, storage, and system so we can manipulate the session context, blockchain state, and system variables respectively. We also need unwrap or revert so we can optionally unwrap objects that might not exist. If they don't exist, we can revert the deploy. Now import these types from the Casper types crate. We'll be using all of these in our project. Now let's define our own errors so we can debug if we run into issues. We'll go through these errors as we write them into our smart contract. Now let's write our call function, which is executed once upon deployment of the smart contract. Our contract will have two entry points, deposit and withdraw. Declare these entry points by creating a new entry points object and adding the deposit and withdraw entry points. The deposit entry point accepts one argument, purse, which is a reference to the caller's funded purse that they'll provide when executing deposit. Withdraw has one parameter as well, amount, which is the amount that the user wants to withdraw in motes. Now we can create our contract's named keys, which store data under convenient string references. Create a new purse and add it to named keys. This will be the purse that the contract's CSPR is stored in. If the balances dictionary already exists or another error occurs, we'll revert with the couldn't create balances dictionary error. Now use the new contract function in the storage module to create a new smart contract in the blockchain state. As we create this new contract, we'll pass in our entry points and named keys that we defined earlier. Lastly, store your new contract's contract hash in your account's named keys, which will make it convenient to access from the installing account. We're now complete with the call function. Let's next write the deposit entry point. First, we'll want to get a reference to the caller's purse that they provided as an argument. Then we'll get the account hash of the caller of the entry point so we can store their new balance under their account. Now we need a reference to the contract's purse that we created in the call function. We're doing that here, and the rest is just unwrapping to the object or reverting with errors. Now we can get the contract purse's balance with system getPurseBalance. And if we can't for whatever reason get the purse's balance, we can just revert with couldn't get purse balance. As an example, we can set a minimum deposit restriction. In this case, we'll do 1 CSPR. And if the balance is too low, then we will revert with deposit too low. As long as the deposit size is sufficient, we can execute system transfer from purse to purse, which will transfer the funds from the caller's purse to the contract's purse. In the event of an error, we will revert with couldn't transfer from purse to contract purse. Now let's get a reference to the balances dictionary created in the call function. We'll do this with runtime getKey, and the rest is just unwrapping or reverting with errors. We can use a match expression to see if the caller has an existing balance. If they do, we update their balance. If they don't, we set the initial balance to that which was transferred, and if there's an error, we revert with that error. This smart contract now supports CSPR deposits. Let's finish by adding the withdraw entry point so depositors can extract their funds. Create a new function withdraw. Start by getting the amount the user would like to withdraw that they provided as an argument. We'll also get the caller, the contract purse, and the balances dictionary, just like we did in the deposit entry point. Just like in deposit, we get the balance of the caller from the balances dictionary. If a balance exists, we check that it's more than or equal to the amount requested to be withdrawn, and if it is, we update the balance and transfer the funds. If the balance is instead lower than the amount requested by the caller, or no balance exists at all for that user, we revert with the error insufficient funds. That's it for the smart contract. Now let's write session code to interact with it. To create a new session code file, which will compile to WebAssembly, head to your project's root directory in a terminal and run cargo new client. This will create a new file main.rs in client/src/main.rs and a Cargo.toml file in client/cargo.toml. Delete main.rs and create two new files, deposit.rs and withdraw.rs. Now open the Cargo.toml file. Now add the following data. Dependencies is a list of dependencies that our contract will use when compiling, and bin is the binary information. Profile.release is a list of release optimizations. Now open the deposit.rs file. Begin the file by writing the Rust attributes noStandard and noMain, which disables the Rust standard library and disables the generation of a main function by the Rust compiler, respectively. Now import the Casper contract crate, including the runtime, system, and account modules, as well as unwrap or revert. Then we'll need the Casper types crate with types U512, runtime args, contract hash, and key. From here we can create our call function. Begin the function by retrieving the amount the user wishes to deposit as a runtime argument. We'll also provide the contract hash of our bank contract as an argument, so grab that too. The contract hash is passed in as a key argument, so we use into_hash to convert it to a hash, and from there build a contract hash object out of it. Now ideally we don't want to expose our account's main purse for security purposes, so we create a temporary one using system create purse. Then we transfer the proper amount from the caller's main purse to this new purse. Since we need to pass this purse as an argument to our contract, we create a new runtime args object and insert the new purse's uref. The only thing left to do is call our contract, which we do by running runtime call contract, passing in the contract hash, deposit entry point, and runtime arguments. That's it for the deposit session code. Let's move on to withdraw. Open your withdraw.rs file, and since withdraw.rs is so similar to deposit.rs, we'll start by copying deposit and pasting it in withdraw. Delete the creation of the new purse and the transferal, as it's not necessary for us to pass a purse to the contract in this instance. Then in runtime args, replace purse with amount and new purse with amount, which will tell the contract how much of the caller's funds it should withdraw. Finally, in runtime call contract, simply replace the deposit entry point with withdraw. We can also delete system and account, as we'll only be using runtime. Our session code is done. Next we need to adjust our Makefile so we can compile the deposit and withdraw session code to WebAssembly. Open the Makefile in the root directory of your project. Copy the build contract target and paste it below the original, changing the name to build client. Change cd contract to cd client. Duplicate the wasm strip command. Change the first's file name to deposit.wasm and the second to withdraw.wasm. Finally, we need to write a few shell scripts to deploy the contract as well as deposit and withdraw. In your terminal in the root directory of your project, run touch deploy.sh, deposit.sh, and withdraw.sh. Add the executable permission with chmod +x. Now open deploy.sh in your editor. We'll be using the put_deploy function in the Casper client. Your command should look like this. Be sure to use an online node address and the correct chain name. We'll create a new Keypair under the keys directory in just a moment. Now open deposit.sh and copy your command from deploy.sh. Change your payment amount from 30 CSPR to 10 CSPR and replace the contract.wasm file in session path with deposit.wasm. Lastly, create another session arg amount of type U512. This will be the amount that the caller sends the contract. To demonstrate a failed deposit attempt, make the amount 0.1 CSPR or 100 million motes. Finally, open withdraw.sh and copy your command from deposit.sh. In this case, we only need to change deposit.wasm to withdraw.wasm and the amount to 1 CSPR for when we do a successful deposit. Now let's compile the contract and session code. Head to the root directory of your project in a terminal, and then run make prepare. Then run make build contract. Then run make build client. Before we can deploy our contract, we need a calling account. Create a new keypair by running Casper client keygen keys, which will create a keypair in the keys directory. You'll then need to fund this account. If on testnet, you may use the faucet at testnet.cspr.live/tools/faucet. Check out video number 3 if you don't remember how to do this. Once you have a funded account, run deploy.sh. We can check the execution status by copying the deploy hash, heading to testnet.cspr.live, and pasting. Once the deploy has succeeded, head over to your account, go to your named keys, and copy the bank contract hash. Now head over to deposit.sh and paste the contract hash, and go ahead and do the same with withdraw. In both deposit.sh and withdraw.sh, change the session path from contract to client, and make sure the amount is 100 million motes in deposit. Head back to your terminal and run deposit.sh, and remember that this should fail because our deposit amount is too low. Copy the deploy hash and head back to CSPR.live and paste it in. As you can see, we get user error 3, which is deposit too low. Let's change our deposit amount to 1 CSPR and try again. Copy and paste in CSPR.live. Now the deposit completes as expected. We can check our account's balance by going to View Account, copying our account hash, going to Named Keys, Balances, Dictionary, and paste. You can see we get 1 CSPR or 1 billion motes. Now our withdraw.sh is already set up to withdraw 1 CSPR, so head back to your terminal and run withdraw.sh. Copy the deploy hash, go to CSPR.live, and paste it in. Our withdrawal has now succeeded. To check our balance, which should be 0, we can go to our account, copy our account hash, go to Balances, Dictionary, paste it in, and we get 0. That's it for this video. If you enjoyed, be sure to leave a like and subscribe if you'd like to see more content. Thanks, and I'll see you in the next video.